Hey guys, welcome back. In today's video, we are going to talk about microservices and event-driven architecture. We are using Spring Cloud Stream with Apache Kafka binder. Well, we are going to cover more advanced topics and best practices. So before going further, please subscribe and let's go. So guys, we have here our customer microservice, and we have also Apache Kafka as our streaming or messaging middleware system. So we have here a Kafka broker. So our customer microservice produces messages to a Kafka topic. So far so good, guys. And we can think, for example, we could scale, right, our customer microservice. So let's add more instances. Now we have 3 instances, and now we can think that we will handle more requests and we will produce more messages. That's good. In the other hand, we have decision microservice. So this decision microservice consumes messages from the Kafka topic, one by one. And it's okay. Now we can compare, right? We need to also increase the performance. We cannot consume it like that. So for example, if we have here a very fast producer, this consumer will not scale, right? So how can we improve this solution? The first thing that comes in our mind is, for example, we can think, okay, let me add more partitions and let me add more instances of our consumer, right? So let's do that. Let's add some partitions. For example, here we are adding a partition, the second partition, and the third partition. So the question here is, what is a partition? So let me give you an analogy. So let's imagine your house as a Kafka topic. So each part of your house is a partition. For example, the bedroom, the kitchen, the living room, they are partition. If your house is a topic, you have some partitions. So this is the first thing that you can use in order to understand what is a partition. And the partition, for example, when you store something in a partition, it will preserve the order that you are storing it. Okay, so this is the main concept of a partition. So going back, for example, a partition we can understand as a small unit in a topic where messages are stored in an ordered sequence. So that's it. This is the concept of a partition. So for example, we use partition to enable, for example, the way that we are going to process in parallel, the scalability. But the main thing that I think that is really relevant here is the fact that it will also allow us the fault tolerance. What I mean, so let's take a look here in this topic sales. We have a Kafka, let's suppose a Kafka cluster, which is a group of brokers or node, right? So we have some machines, and in these machines, which are Kafka brokers, we have our topic, which is our sales topic. And when you use partition, for example, we have here 3 partitions, but the first partition, you can see that it's located in the broker A. But we also have the same first partition in the broker C. So for example, if the broker A goes down, we still having here our partition. We still can consume from this broker here, okay? And so on. So Kafka have a concept called by leader, election, the replication factor, and so on. So in order to just try to visualize it, okay, let me just show you what I mean. So let's take a look here. So we have our producer, we have a broker, and we have our consumer, okay? So in this broker, as default, we have only one partition. So this is the broker, this is the partition. We have one partition. So what happened here is the fact that, for example, our producer produced a message and our consumer is consuming the message and sending the acknowledge to the broker, so it can increase the offset. Remember, Kafka has offset. Go and read a little bit more about that. And it's happening normally. So now The first thing that we can think about is, for example, let's add one more partition, We just know what is partition. So we have here our broker, we have the topic, right? Let's add one more partition. So we will have two partitions, and now our producer will send the message, and the message can go to the first or the second partition. So this one here or this one here. So now we can think, okay, now this is the place, okay, this is where we can start thinking about scaling our broker. So for example, we can, now let's suppose the first thing here is, for example, if we lose this broker here, our producer will not be able to produce any more data. So we will lose this, okay? So let's keep on. So we have our broker working. Now we need to scale it. The best practices is that you can, when you create a Kafka cluster, you must have at least, let's suppose, 3 brokers. But in our example here, let's add one more broker. And now you can see that for each broker, we assign for each broker one partition. So in the first broker that we had, we have the first partition, and in the second broker, we have the second partition. So what will happen here, for example, if we lose this broker here, the second broker still receiving the messages, but the consumer cannot consume, okay, the messages that we had here in the first broker. Now let's turn on the first broker. So everything is working perfectly. But how can we solve this issue here? The fact that we cannot, for example, consume, okay, these messages here. So this is where we can think about the replication factor. So adding partitions like that will not solve the problem related to fault tolerance. So let's turn on our broker. Okay, now we have 2 brokers, 2 partitions. And now let's add the replication factor to 2. Now pay attention here, what will happen? Okay, if you pay attention, now we will replicate each partition, okay, in both brokers. So for example, the first broker will contain the first and the second partition, and the second broker will also contain the first and second partition. Where, for example, here in the first broker, okay, here, let's suppose here in the first broker, we have here the partition 2 is the leader, okay? It is the leader partition, but here it's just a replica, okay? So we just replicate. The same will happen here. The first partition here in the first broker is the leader partition, and in the second broker it's just a replica. So what's happening here is every time when we produce, let's suppose here, a message to a partition, it will replicate in both brokers. So as you can see here, 51, 51 here, 52, 52 here. So what will happen here is if I turn off this broker, I am still having here all the messages that I had here. So our consumer can consume it, okay? So this is something that you should understand. The replication factor is very important. I just replicate, for example, I can give one more replica. It's not allowed, okay, because you should have as more as broker, okay. And now 3 replicas. So I will have, for example, here 3 brokers, 1, 2, 3, 2 partitions, and I will have replicas. So if I have some problem in both brokers, I still having it here. If I have, for example, 2 brokers, it's okay. So this is the first thing that we need to understand here. I hope that it's clear. You have this very nice visualization, the very nice Kafka visualization from Software Mill, and you can just play with that. It's very simple, very nice to understand the very basics and advanced topic about the Kafka, partitions, brokers, and replications. And we are coming back for consumer groups. This is what we have just seen in the previous example. And the other thing that I would like to mention is, for example, when, as we saw there, when the messages have no key, the deliver will be using a round robin. So for example, it will use, just as in our previous example, it will just send to random partitions, okay? So if you want, for example, for a message to go to a particular partition, you should associate the message a key. So going back here, for example, now we have here in our decision microservice, it's consumer from different partitions. And what I was telling you guys is, for example, if you have, for example, if you have 3 partitions and 1 consumer, the consumer, this microservice will consume for all those partitions. And it's okay actually. But sometimes you want to, let's say, to have more performance, which is the main topic here. We want to consume more messages. We have we want to scale, right? So in that order, for example, the first thing that we can think, right, is to add more instances of our, let's say, consumer microservice. Just as we have here, we have 3 instances of our producer, which is customer microservice. We will need also more instances of our, let's say, decision microservice. So let's add 3 instances, and so far so good, it's okay. Now, the problem here is if you do something like that, what will happen here is we can end up with duplication. So be careful. If you increase, or if you, let's say, scale, if you increment the instances of your decision microservice, which is consumer here, right, it can duplicate messages. Now let's take a look back. So if we take a look here, we have our, let's say, first consumer, right? But what we need to do is something like this. So here we have 3 consumers, right? So in our visualizer, we can add also more consumers, just like that. For example, let me add consumer here, and let's add 1 more consumer, just like this. So if we add more consumers without specifying anything, it will duplicate. For example, let's suppose that all those 3 consumers are the same, let's say, the same application. All the 3 consumers are our decision microservice, just like that. So if we do something like that, all of them, they will consume the same messages. As you can see, all of them are consuming the message number 27, right? All of them are consuming the message number 28, and so on. And this is very bad. This is very bad. So for example, if you think about the decision, it's okay. But if you have, for example, a microservice that is dealing with money or deposit or something like that, it will cause a business problem, because you will, for example, instead of receiving 10 euros, you will receive 10 euros 3 times. And it's very bad, right? So how can we solve that? So in order to solve that, in Kafka, we have a concept called by consumer group. So let's take a look here in our visualizer. So we have 3 consumers of the same application, right? 3 instances of the same application consuming the same message. So this is where the consumer group comes into action. So you have to specify and tell that all those 3 consumers are the same application. So as you can see, now that I apply it, only 1 consumer will consume, okay, a message, a particular message. Now you can see the 40 here, for example, the 57 is the first consumer, the 47 is the first consumer, the 48 is also the first consumer, it's also the first consumer, and there will be, as you can see here, right, a time where they will start consuming different messages, but not duplicating. Now, let's go back here on our presentation in order to complement. So when you add the consumer group, actually you have to think like that. So consumer group in Kafka, a consumer group is a group of consumers that consume the message in collaboration. So when you use consumer group, you are actually enabling the parallel processing and so on. And the next thing that I can think about that is, for example, if you have 3 partitions in our consumer group, each partition will be assigned for a particular consumer, just as we can see here. So for example, the first partition has been assigned for the first consumer. The second partition has been assigned, okay, to the second, let's say the second consumer. But for example, here we can think, okay, now we can add one more partition. I think it's okay, just like that. And as you can see, now our, let's say our third consumer, okay, will also consume the message. So going back here, for example, we can think, okay, let's suppose that we have 3 partitions and only 2 consumers. So you understand that one of them will, right, consume two partition and one will consume to 1 partition. It's okay, it's clear here. Consumer group is also important because it also allows fault tolerance and rebalance. And as you can see, for example, if a consumer goes down, Kafka will pass, okay, the partition that was assigned to that consumer to another consumer. Yeah, guys, as you can see, it's amazing work here. If you don't understand something, just leave in the comment section. Don't forget, guys, subscribe, put some like and so on. Let's keep going. And yeah, now as I was telling you guys, that each consumer will be assigned to a partition. So our consumer here, green, will be assigned to this partition, the blue will be assigned to the other partition, and this will be assigned to the other partition, just as we have here, like this. Okay, first partition, first consumer, second partition, second consumer, third partition, third consumer. Easy to understand. Okay, and now when we produce the message, okay, as our producer is producing the message, okay, we can see that we are consuming in very fast way. Now, going back here in our presentation, we already understand that the message key is important and so on. We talk about the message key, but let me just make it a little bit more clear, is the fact that if we, for example, assign a message key in partition, so for example, let's suppose that our customer microservice produce a message customer created and the customer ID is 1. So if we use this ID 1 as message key, every time when we receive a message which contains the message key with this specific ID 1, it will be associated to a particular partition. So for example, if we create a new message, for example, customer created with ID 2, it can go to another partition. But the most important thing here to understand is, for example, for the same customer, if we receive a new event, okay, called by, let's say, email changed, okay, customer email changed, the customer ID as a message key, it will go to the same partition. So customer created and customer emails changed for this particular customer ID 1 will go to the same partition. It will allow us to consume, when we consume in our consumer side, in order. Okay, so it will preserve the order of the message. Without that, for example, we could have our email changed to another partition and another consumer will consume first the email change before consuming the customer created. So now, guys, now we have everything okay, everything is working okay. If we take a look here, even having partitions and so on, our consumers are consuming messages one by one. So what I mean is, for example, here, right? Let's take a look here in our example. So we have our consumers, they will consume, right? They are in the consumer group. We have 3 partitions, right? One will consume it, consume. So they are consuming all of them in the particular partition messages one by one. So for example, if we have 5 million messages, let's suppose it can take 5 minutes. So now the last thing, how can we solve that? So this is where we use the concept called by consumer batch mode. What will happen here is that we are going to apply a batch size in our messages that will allow, for example, our consumers to consume in batch instead of consuming one by one. So for example, we had here another batch size, just like that, okay? Now, all consumers, okay, will consume the messages in a batch mode. So, like this. So instead of taking, for example, 5 minutes, it can take some seconds. Of course, I'm just illustrating here, but you must understand the idea behind this topic, okay? So guys, talk is too much. I don't like to talk a lot. Now let's code it. Let's see how we can consume, okay, messages in batch mode using Spring Cloud Stream with Apache Kafka. So let's go, guys. So guys, we are here on our IntelliJ. So if you are new in this channel, this is our decision microservice, and we have done many things with this microservice. So you can just, for example, clone the Git repository, and remember, for this particular video, the starting point is the branch called by feature integration test consumer side. So for this particular Git branch, we can just create a new branch, and let's say, for example, that we are using here for consumer Yes, so now that we have here our new branch, remember, we have something here. Right, now let's go to our messaging package, and here we will start implementing our consumer batch mode. Before that, let me just delete this one, and yeah, I think it's okay. So the first thing that we need to understand is that if you are using Spring Cloud Stream with functional binders or functional interface, you should understand that for consumer, you use the consumer, right? As well, for example, the producer, you will use supplier. They are pure Java functional interfaces, okay? And you should take advantages of it, because as you understand the consumer, you are handling, you are consuming a message. So in that order, let me just use here, customer created is the event that we are going to consume, and the name of the method, I will just call it by process customer created. And here is the place that we are just going to, for example, handle, right, the customer created. So the method is this one here, which receive a customer created, and as well we are consuming, right, the customer created here. So for this particular one here, we can just, for example, replace it with method reference instead of lambda expression. So it will be, I think, a little bit better. And the next thing that we need to do is to annotate it as a bin. You remember in the previous video, you need to annotate your functional, let's say, interface, okay, as a bin. And the next thing that we are going to do here is, for example, let's just comment this line here. And I think, yeah, everything is okay. So in order to test our application, the first thing that I'm going to do, let me just see if I have Kafka running. All right, I have here Kafka running. So let's go now. So now let's go to our producer microservice, which is our, let's say, customer microservice, okay? And let's run our customer microservice because we want to consume an event, so we have to have a producer, right? So now that we have it like that, the next thing that I'm going to do is, let's just go here on our Postman here, as you can see. Yes, so we have here a customer. Let's just create this customer. Okay, we have the customer here. Now let's check if we have the event. But before that, I think we have to docker compose app akhq. So just like that, let's run our akhq. So what is akhq? akhq is just our user interface that we use in order to visualize our Kafka topics and, for example, schema registry, the connectors, and so on. Okay, so In that order, we can just go here on our browser. We can just call the local host, which is the port that AKHQ is running. And then, as we can see here, we have an event, okay, which is the customer created. So if we take a look here, for example, we can just create a new customer. Let's just say here, for example, Elon Musk, and let's just let it as a first email, okay, like that. So rerun, and let's take a look here. So we just need to give here a refresh, and then we can see here some seconds ago we have the Elon Musk customer created. Okay, so far so good, guys. So now let's run our consumer microservice, which is the decision microservice. Remember, we have all the code shared on our Git. Okay, let me see, it's complaining. Okay, I think for this particular case, let me just see, web application. Okay, it needs, okay, it needs a, we didn't specify for this application. Let me just see here, web. Okay, so as we don't have dependency for our servlet, I think the first thing, I think we can just, for example, do it like this. For example, spring.main.web, I think it's like this, web application type is equal none. So it will suppress the error. All right, here we have, but we still having some errors here. Entity manager. Okay. Unknown database. So I have just created here the database decision. Okay, so everything is working now, I hope. Let's run our decision microservice. All right, as we can see, our decision microservice is consuming the messages. So the events that we have here, our decision microservice is consuming. So in order to prove that, let me just, for example, stop our application, run it in debug mode. So in that order, we are going to put here a breakpoint, and we will see once we create a new customer. Let's just put here, for example, Kendrick, and it should consume, as we can see, the topic name is customer, not customer topic. So we can just, for example, delete this topic here, and let's go back to our decision microservice, and let's restart the application, providing the correct topic. And now you can see that we are going to process the first, we are processing, for example, the first customer, which is Markovich, the second one that we have created, which is Elon Musk, as you can see here, and the third one is Kendrick Lamar. Yes, so far so good, guys. I think in order to make it better, let me improve this code. So now what's happening here is when we consume events like that, actually we are consuming events one by one. And as I was telling you guys, that what we are planning to do here is using the batch. Okay, so we are going to use the batch mode in order to consume the event. So in order to do that, is very simple, it's very easy. Okay, so the first thing that we need to do is actually we are going to provide a mean. As you remember, guys, we are using this binder here. So in that order, we need to say, okay, for this particular binder, for this particular topic, right, that we are consuming, this binder will consume using the batch mode. So in that order, let's just go here. Let's use the Spring Cloud Stream. Then we specify bindings. and then we say the name of the bindings that we are using. In our case is this one here. And after that, we say that, okay, for this particular binder, the consumer, okay, we are enabling the batch mode, just like that. And we here pass the flag as true. Another thing that we can do, for example, we can specify for each particular binder, but we will see, is that we can, for example, say Spring Cloud Stream should use for Kafka binder, we are going to say that, okay, we are using the consumer properties, just like this, and we are going to say, okay, for example, so when you think about chunk or batch, you think about, for example, the batch size, right? For this particular case in Spring Cloud Stream or even Apache Kafka, we have to say the max poll size record. So if you remember, in Kafka, we don't say, for example, messages or events or commands. We say record. In Kafka, everything is record. So a record can be a message, the way that your application will deal with that, okay? So in our case, let's say, for example, we are going to poll for each time, we are going to poll 5 records, okay? So before doing that, let's create here, let's publish, for example, some data. For example, here, now we have Kendrick Lamar. Now we are going to add Celine Dion. I will just create, for example, 10 records, and we are going to process them using the consumer batch mode. So I will be back once I create all the 10 records. So I have just created here the last record, as we can see here. So now we have 32 messages to consume. And yeah, so let's go back to our consumer microservice. And the first thing that we have done here, right, we enabled the batch mode configuration, and we say that, okay, each time we are going to fetch only 5 messages. I think later we can see the documentation of Apache Kafka, and we will see what is the default size, but I think it's 500. So having it like that, it's not the endpoint here. But yeah, the next thing that we need to do here is, for example, if we just consume the messages like that, the way that we have here right now, it will still consuming one by one. So the first thing that we need to think always is that we are now consuming a collection of messages. So in that order, I think we can, for example, let's just put it like this: customer created message, right? Because it's a list. Customer create customers should be like that. Customers created. But let me just put it for simplicity, okay? We are just going to see here. So we are going to say, that each customer, okay, we are going to handle it by using our method that we have here, okay, just like that. So once again, method reference is better than lambda expression. And yeah, for now, let's just put it like that in order to see, because we are going to put here the breakpoint. Let's run our application. Remember that we are consuming, okay, all the messages that we have here. So if we go back here on our topic, we can see that we have 32. So now that we are going to consume, let's run our application, and let's see that it will actually, for the first time, will pick 5 messages. So it took the 13 messages. I think that the property, but as you can see, guys, it's working. Now we are consuming, instead of one by one, okay, we are consuming a collection of messages. So we have here our consumer consuming in batch mode. But I think we have done here a mistake. Let me see, Spring Cloud Stream, yeah, Kafka binder, then consumer property that max poll that record. Oh man, it's records because it's 5, right? So just like that. So before that, we can see, okay, now we are going to consume 13 messages at once. But let's stop this. Let's create some more records just like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have here 11 messages to consume. Now this time it should work as expected. The last time also worked, but it's not the behavior that we wanted. Yeah, now the application is running. Okay, yeah, as you can see, this time, the first time, we are consuming the 5 first records that we have specified here, right? And remember, we just put here, for example, instead of receiving a simple customer created event, right, we are receiving a collection. So it could be, for example, if you are dealing with a message, right, if you are wrapping all your message like this, you could also, for example, consume it like that, okay? But for our case, as we can see, it's consuming 5 record first time. Then we are going to process, okay, the records. So let me see like this. Yes, it's okay, it's working. We can, for example, try once again to create some more messages, and then we are going to consume the messages in batch mode. So in that order, let's just put here, for example, Jane Doe, like this. Once again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 even. Let's see what will happen if we have 11 messages to consume. So now let's run our application. And okay, we are consuming the first, right? The first batch, which is 5, as we specified. Now let's go to the next one. So it's consuming the first chunk. Now the second one, also 5. We consume 5 messages, and then we have the one remaining. Okay, so and that's all. So this is the first thing that we can think when we are dealing with batch mode in Spring Cloud Stream. But I can tell you guys that, for example, we can go to, let me just go here on our browser. So now that we are here on our browser, yeah, configurations, just like this. And let's look for, we can see here, for example, configuration sync, which is the consumer. And you can see here that default value of max poll records, as we specified here on our application, right? Max poll records, okay, is 500. So here we are telling about the max poll, how many messages, the number of the messages that we are going to consume at once. But apart of that, you have some other properties. For example, fetch that, max bytes. Yeah, as you can see here, the maximum numbers of bytes we will return for the fetch request. And you can play with that, okay? For example, here you can just go, for example, I can just copy this property, which is the same. I can just go here on our application, duplicate it, and just replace, for example, here. And you can just, for example, say, I don't know what is for example, here you can just say, you can duplicate it, and it will be 2048, right? So take a look at the documentation. The sync is the consumer, the source is the producer. Also, producer can be using, for example, batch size and so on. Now, before going to the next topic that I want to cover with you guys is, remember when we were talking about the retry mechanism using Spring Cloud Stream? So be careful, because when you add the batch mode, when you enable the batch mode, the retry mechanism will not work anymore. So for example, here we are retrying, right, 3 times. When we add it like that with batch mode, it will be set to 1 automatically. I think this is the correct behavior, because you are consuming, right, messages in the batch mode, and you can think another strategy that you can, for example, have the retry mechanism and so on. Yes, so now let's go further to another topic, which is the concurrency. Okay, so we are going to talk about concurrency while using Spring Cloud Stream. So we saw here that we are consuming in batch mode and everything is okay. So this way we can scale our Spring Cloud Stream application. We can scale our microservice while handling events. Using batch mode, we scale it. But I have to tell you that we have another stuff here that I want to share with you, which is the concept of concurrency. But before that, let me just go back here on our presentation and let me talk about partition. So if you remember, guys, we were talking about partition and you understand the concept of partition, right? So for example, if you have a topic, right, the topic is your house and partition is each let's say part, okay, of your house. And yeah, so if we take a look here on our topic, let me take a look here, we can see that our customer topic only has one partition in total, right? In general, one partition. And if we go back here, we understand the concept of partitions, right? We have here 3 partitions. So we have here, right, 3 partitions and 2 brokers. If we go back here, we can see that our topic has only one partition. So in that order, let me just first of all go back here on my producer application. Let me just stop the application, which is the producer. The customer microservice is our application producer. Now that I have my application like that, the next thing that I'm going to do, I'm just going to delete this topic and I'm going to create a new one. As you can take a look here, just take a look here. We are going to create a new one. Let's just call it by the same customer, right, which is the name of our topic. And here we are going to specify 3 partitions, for example. Okay, and you can also, for example, understand a little bit about the log compact or compact mode, delete compact, and so on. But I will create a new video in that order. But don't forget, subscribe, put some likes here, guys. Support the channel. So now let's create our topic. Let's take a look. All right, now we have our topic with 3 partitions. Now, let's talk about concurrency with Spring Cloud Stream. So when we talk about concurrency, actually, now that we have 3 topics and we have our application, which is decision microservice, we have only one instance, right? Even if we are consuming in batch mode, we can still improving the performance of that. So the concurrency comes when you have, for example, more than one partition. So for example here, what will happen here is that our decision microservice, for our particular case, let's go back here, we have 3 partitions. When you enable the concurrency feature, Spring Cloud Stream application, in our case our decision microservice, you can set, okay, the number of concurrency that you desire. For example, in our case, we are going to set 3 concurrency. So what will happen here, it will create one more thread and another thread. As we have 3 partitions, our threads will be assigned to a particular partition. So we will have a single application, only one instance. We have a topic with 3 partitions, as we have here. And then when we enable the concurrency mechanism, we specify the number of concurrency, for example 3. The 3, okay, will create 3 different threads for each partition, which will allow, for example, in our particular case, more scalability, right? We will improve the performance depending on where you want to solve the performance. So let's go to the code. Let's see how we can deal with concurrency feature. Now let's go back to our decision microservice. So now the first thing that we need to do here is the simple fact that we need to specify that, okay, Spring Cloud Stream, for this particular consumer, let's say, for example, we are consuming in this customer, right? This is the customer topic that we are consuming. We are going to say, okay, I want to enable concurrency and I will specify the number of the concurrency. So in that order, you just need to specify Spring Cloud Stream. And here is the place that you say, okay, bindings, right? Always bindings. Our binding is this one here. Let me just copy, paste it here. And then as we have it like that, we just specify, okay, we are dealing with consumer and then you specify the concurrency. Okay, so in our case it will have 3 concurrency. Now let's go back to our producer microservice. Let's start it just like this. All right, this is the time that we need to start also our consumer microservice. Okay, now let's take a look here. Okay, there are some things that we need to take a look here in the logs. So for example, if we take a look in our logs, we will see that the decision microservice partitions assign customer 2, and we can see here also assigned to customer 1, okay, and also partition assigned to customer 0. So what's happening here, if we take a look here, it creates a container. That's why we say like, okay, it's concurrency. So we see container 1 C1, so container 1 concurrency. Okay, so here it was the third. Okay, so the third thread was assigned to the third partition. Here the second one, right, was assigned to the second partition, and here the first thread, which is 0, right, was assigned to partition 0. So now I will just go here and let's use here our Postman. I'm just going to produce some messages or some records or some events in terms of our application, right? In terms of application, we are talking about events. Okay, in terms of middleware or enterprise integration patterns, we are talking about messages. So in terms of Kafka, it's record, but we can interchange the concepts. So now let's go back here. I just produced some events. If we take a look here, okay, we have 20 messages, and as you can see, some messages. So the first one went to partition 0. The key number 2, which is this event here, went to third partition, which is this second partition, and so on. The first event went to the first partition, the second one went to the third, for example, and the fourth one went to the second. Okay, so we have our partitions working. Okay, now this is the time that we need to, for example, once again, okay, let's run our consumer microservice, and we will see that it will consume in batch mode, but also in it will use the containers, it will use the concurrency to process messages. Okay, so for example, if we take a look here, the decision, now let's take a look here while processing. Okay, so if we take a look here, it's processing the customer created message, and it's using the thread number 0, and here it's using the thread number 1, right, and here it's using the thread number 3, which each thread here has been assigned to a particular partition. So for this particular case, our application is running, so it's a single instance of our application. But maybe you are using, or your application has been deployed in a cloud, right? So running on a Kubernetes, on Amazon, or OpenShift, or something like that. And maybe you want to scale your application. So actually you can take also advantage of this kind of scalability, right? So for example, you could use the same approach, so you can scale from one more instance. It will be like this, right? So you will have the same approach, but with 2 instances, or you can, for example, increase one more instance. Yeah, it could be amazing. So in our case, we can also do that. For example, we can just go here. Let's just give an example. Let's just go here on our IntelliJ. Let's use modify operating system, allow multiple instances, for example, like this. Let's apply. So we will run our decision microservice with, let's say, I think, yeah, 3 instances like this. And yeah, but before that, let me just take a look, for example, here on our topic, let's put, for example, 9 partitions, right? Because now we are going to deal with, let's say, we are going to deal with 3 instances. 3 instances, 3 partitions, it's okay. And we are using also concurrency, it's okay. But let's try to improve a little bit more. So in that order, before going further, let me just stop for a bit our producer application. And let's go back here on our topic. I will delete this topic here. And now I'm going to create the same topic, but with more partitions. So customer, of course, I could just update it, but let me put here 9, right? Because we have 3 instances, and we are also saying that each instance, right? Each instance will run with 3 concurrency. But you could use a single instance with 9 concurrency, just like that. But in my particular point of view, it's not nice even for this video. Okay, so now that we have our topic with, yeah, let's create, I didn't create it. Let's create customer. Okay, we have 9 partitions, and here let's run our producer application. Our producer is running, and it will run, of course. Now let's start creating some random events, messages, or whatever you want to call it. But in our case, are events, because it's something that has happened in the past. Okay, that's why we are calling the events as customer create, right, in the past tense. So this is the event, and you can understand also it as a message, but to give you more semantic and domain like language, okay, let's call it by event. So we have here, well, 25 customers, right? We have produced a lot of customers. And now if we go back here, we can take a look here, 25, but the count is 50, doesn't matter. Okay, just like this, as we can see, we have 25. And each of them, you can see, 1 went to 0, 2, 2, 1, and so on. So we have split our messages in different partitions. So now we are going to run our application. Whoa. Actually, I think 1 will consume all of them. Yeah, but anyways, let me just run our application. Where is the consumer microservice? Let's go back here, decision microservice, and here, let me check. Okay, we have allow multiple instances, and I just forgot how to run with multiple instances, but anyways, I will run 1, 2, 3. Okay, we have, okay, yeah. So now we can take a look here. Okay, as we can see, so most of them, they are using, okay, they have been assigned to different let's say partitions. So for example, the first instance with 3 concurrency, right, it was assigned, let me see here, for example, yeah, so for example, the first instance was assigned to partition 0, right? We are talking about partition assigned. This is the name of the customer, and this is the partition. So customer is the topic, not the name of the customer. This is the topic name, customer, and this is the partition 0. So just like this, for example, this partition here, 0, in our topic, which is customer. So it was 0, 5, and 8, the first instance. So for example, just like in our example here. So this first instance was assigned to 3 partitions. And also, if we go back here, this is the first instance running. You can take a look here. We are running 3 instances. The first instance, 3 partitions. The second instance was assigned to 1, 3, right? 1, 3, and 6. 1, 3, and 6. The third instance was assigned to 2, 4, and 7. Okay? So now if we, for example, produce some messages and so on, just like this, we will see, okay? We will see all of them, they are consuming, right? From the partitions that they were assigned, okay? So the first one is consuming, the second one also is consuming, and the third one is also consuming. And all of them, they are using, okay, multi-threads. So concurrency is 3. Each partition contains 3 threads, okay? You can play with it, but this will boost your performance. And remember, always take a look, see where you need to improve the performance. Maybe it's not necessary, but we are talking about improving the performance of our event-driven microservice and our application, which we are using Spring Cloud Stream, which is amazing framework. So before going further, maybe the last thing that I would like to share with you guys is, for example, now that we have only one instance, okay, let's go back to one instance, and we have, for example, here concurrency 3, right? But in our topic, we have, let's go back here, in our topic, we have 9 partitions. So what will happen here is the fact that as we have 9 partitions, we need actually, not we, but Spring Cloud Stream will actually assign all 9 partitions to, let's say, our single application. Even if we mention here, right, that we only have 3 concurrency. So, for example, each concurrency, which represents a thread, right, will be assigned to, let's say, as we have 9, right, we have 9 partitions and 3 threads. Each thread will be assigned to 3 partitions. Let me just go back here. So we have 9 partitions, right? And yeah, so now if we run, let's suppose that we are running for the first time, even later, because Kafka will rebalance. But now if we run only one instance of our application, we will see that, yeah, we will see, as we can see, the only instance that our application has, okay, for each thread. So for example, the third thread was assigned to 3 partitions, okay? And yeah, the second one was assigned to 3 also, and the first one, right, the first thread for this topic, okay, was assigned to 3 partitions. Guys, I think this is very nice topic to cover, and I have more to come, but I need your support. You really need to put some like. Don't forget, put in the beginning of the video. Don't forget to put your like, subscribe, and leave a random comment. Just say, yeah, nice. It's like that. And yeah, I will make more videos for you guys. Or just go to Udemy, buy something. We are giving you free material. So see you in the next video. Bye bye.